Hello everybody, welcome to this webinar. My name is Michael Wiendl, I'm an NC trainer at HEIDENHAIN TNC, and today I want to show you the deburring components of the TNC controls. First, a little overview about the content. So we take a look at the possible applications. In the next step, we show you the examples how to program an NC spot drill with a 90 degrees T angle for deburring. And then we take a look at two example programs from our NC solution page, how to program an angle or a radius on a contour directly on the control. So an overview about the possible applications. So I think the most application is the easy chamfering with a spot drill tool with a 90 degrees angle. When we have a 45 degrees chamfer on the workpiece, and therefore we can use our normal spot drill tool, and we can also use our normal milling cycles, so the normal NC program for the later on chamfering process. And also we have two different example programs to show you how you can easily program a free radius and angle on a contour directly at the control. And these two examples you can find at the NC Solutions database, where there are a lot of NC programs to help you directly on the control. The most applications, I think, will use the normal NC spot drill tool. So we use a 90 degrees T angle tool, and this tool is measured on the radius, so the biggest radius outside, and the length is the theoretic corner of the tool. These values are in the tool table, and we use inside of the NC program the delta length and delta radius in the tool call just to bring the cutting point directly to the 90 degrees angle side from the tool, so that we get a real chamfer, and also we can see the chamfer in the test run later for the simulation. So here you see the example. So the tool is measured in the length at the theoretical tool tip, and the radius, the biggest radius of the tool. So normally the control will lead the corner here. But there you can see there is no cutting material. The cutter is here at 45 degrees. And so we just use the delta length and the delta radius to bring the leading point to the cutting side here of my cutting tool here. And the important thing is the delta length and the delta radius together must always be the radius. So when there is a radius 5 and I program delta length -1, I must program delta radius -4 to get the correct situation at the tool. Later on in the cycle, I just program the depth. This will be the chamfer size. And this is the example from our NC solution database. There we find milling a chamfer on a contour. There we can use a different angle or a different length of the chamfer, and this will be automatically calculated on a contour what I can define in a label. And this is a very good thing just to help us here with the programming directly on the machine. So you can see here the screen, and the advantage is that we can use different tools. So we can use this example with an end mill, with a ball nose cutter, or with a torus mill. So these different tools can be used directly with one example, and the control compensates the corner radius of the tool. And the same example we also have for radius. There I only input the size of the radius, and then the contour just automatically calculates it around the programmed contour, and that's an easy way for me just to do it like this. And these examples, you can see here the link. We can take a look later on the Klartext portal, and there we find these programming examples very easy, and we can download it for free and transfer it to the control and use it directly on the control. So let's go to programming station. Here we have our programming station, TNC 640. Then I show you how to define such a deburring tool. So in the tool list, we have a lot of example tools inside. And here we have our already deburring tool. And the main thing for the deburring tool is the T angle here. The 90 degrees. This is the T angle for the tool. And this T angle will also be shown in the test run mode. And so we can also use the chamfering in the test run to check is everything okay or not. So the program is a simple program. At first we have the roughing. It's a contour and a circular pocket. So we just take a look at the program. So you see just an outside contour and a simple circular pocket. And in the next step, we will now do the chamfering on the contour and the chamfering on the circular pocket here. For this, we go to the programming again. So I input a new tool, just to show you how to program such a deburring tool. We input the spindle speed and the feed rate, and in the next step the delta length and delta radius. So the chosen tool is a diameter 12, so radius 6. So when I program delta length minus 2, then I need the delta radius minus 4, because 2 plus 4 is 6. The tool above, you can see it's a diameter 10, a radius 5, so 2.5 plus 2.5 is 5 millimeter again. So always delta length and delta radius together must be the radius of the tool. Then the calculation is correct here. And then we have our simple cycle, for example, cycle 25, contour train. And here I program the milling depth. This should be minus 0.5 millimeter. So this is the size of the chamfer. And everything else is just standard input. And then we can take a look at the sentence here. And now we saw that the chamfer is already on the contour here. So let's make it a little bit slower. Yeah, and here we see that the tool is leaded exactly here on the cutting side on the 45 degrees. That's because of our delta length and delta radius. Of course, when I want to have the cutting point closer to the middle of the tool, then I make a small delta length and a bigger delta radius. If I want to have it on the top side here, then I make a big delta length and a small delta radius. So we can just make the example here. So I make a small delta length and a big delta radius. Then you can see we are down at the tool side. And when we just switch around, we make a big delta length and a small delta radius. So always delta length plus delta radius must be the radius. Then we can see that the tool is now guided here. So this I can easily just control with the delta length and the radius of the tool here. So now outside the chamfer is done, and the next step would now be the chamfer for the circular pocket. And there we can also use the same tool and just program in the cycle machining operation 2. So just finishing, and we define an allowance for side 0.2, that the control knows how much material are for the finishing on the workpiece. Everything else, the cutting depth is for our size of the chamfer, and allowance for floor I program 0, otherwise the control would also do the finishing on the floor, and I don't want to have this, so that's why I say here 0. Then we can say go to 32 and just and here you see the same chamfering also for the circular pocket, and that's an easy way to program a chamfer directly on the control with our milling cycles and everything. And if you define it like this, you can also see the result in the simulation, and then we can also check if the size is okay or not. And then I want to show you the examples from the NC Solutions database. This is already the example. I show you also how you get this example. So on the klartext portal, so klartext-portal.com, you can find a lot of information for our NC controls, tips and tricks, training, our HEIDENHAIN online training, also a lot of information, other webinars, videos, manuals, and under tips you find the NC Solutions. And this is a database with a lot of NC programming examples for FAQs, NC programs, for programming station, for tips and tricks. So you see a lot of different possibilities. And here under applications, we find the deburring and chamfering. And then it shows me the programs what are together with this settings here. And for our example, it's milling a chamfer on a contour. And here you see now program descriptions, for example, a PDF file. Inside of this file, you find a detailed program description and also an example drawing and also the parameter settings. So what are the parameters responsible for which behavior or for which entry in the control. And here you can just download for free the program file, and this you just easily transfer to the NC control, and then we can use it directly on the NC control. Of course, there are a lot of other examples. For example, when you want to do the chamfers on a 5-axis simultaneous machine, there we also have an interesting example, also with a video here, where we can just show you the possibilities here. So first the roughing, and then here you can see now the nice simultaneous movement. So if you just have a circle or a rectangular form, then you can also use this Heidenhain parameter programs to make a chamfer with a 5-axis simultaneous machine. And this is an easy programming example. Just download it for free from the NC Solutions database. Yeah, and our example would be now the milling the chamfer. And the first example here is just the outside milling. And here we have now the parameter for the chamfer. So the 30 degrees is the chamfer angle. The 0.2 is the step from in the z-axis. And the 2.5 is the chamfer length. And then the call label chamfer. Inside of the call label chamfer is now all the calculations from our side, but they are not interesting for you. For you, it's just interesting to input the correct values in these lines, 32 to 36, and then just program the value like you want. And the advantage of this programming example is that you can use an end mill cutter, and Torus mill cutter, and also a ball nose mill cutter all together with one program, because the calculation here in the label chamfer will compensate the R2 of the tool. And that's why we can easily use different tools with inside of the same NC program, and the program will automatically compensate these values here. And the same example we also have for the radius. Also here you see a simple contour. So we define the contour in a label, and then we can easily say which radius we want to have, and also the step for the radius. So if it should be more fine or more roughly, then we can decide it with the input here. So just to show you, at first it's just the roughing, so the preparation, and here we can say I want to have an edge radius of 3, and the in feet in degrees, this is the step for the radius, so more fine. So as smaller you make it, then it's more fine. As bigger you make it, then it's more rough. Then we can say here also 2. and then we just switch, and now we have a radius 2 on the contour. And this is an easy example just to show how you can program a radius directly on the control on a free contour. And of course, you do not have to program it by yourself. You can easily use here the examples from Heidenhain. Just copy it to your control, and then you can test it and try out if everything is working with your control. The nice thing with this example is that we can also use it with different tools. So for example, I change to a torus mill tool with a radius 2 of 3 millimeter, the corner radius, and then it's all automatically calculated that we can use it with another tool here. Of course, we can also use it with an end mill cutter, but when you have no corner radius, then you need really small step to get a good surface quality. And these examples, they are free. You can just download it from our homepage, and then you can transfer it to the control. Okay, that was all from my side. I hope I could give you a hint for new programming exercises that you can do the chamfering, the deburring easier on the control. Of course, if you have questions, do not hesitate to contact us. Just use the phone number or the email address, and we can give you as quick as possible a suitable answer for your question. So thank you for listening to this webinar. Have a nice day and bye-bye.